Hello and welcome back. In this video, we're going to explore two other variations of this chain rule. So in each case, I'll give you a relationship between variables and then expect you to figure out what the chain rule is for that situation. So in this case, I have W depending on X, Y, and Z, and then X, Y, and Z each depend on S and T. And what one might want to know is how does W change with respect to S, and how does W change with respect to T? So we want chain rules for these two quantities given this situation. Now remember, right, if you want to think, if you want one chain rule for functions of several variables, then it's tree diagrams. So that is, we have W depending on X, Y, and Z, and each of those depends on S and T. So if I want partial W with respect to S, right, what I can do is I'll follow every chain that ends in S, so starting at W and ending at S, this one, this one, and this one. And then move down the chain. So we should have three terms, each with two factors. So going through X, partial W with respect to X, W with respect to X, times partial X with respect to T, with respect to S, plus, so I ended there. Now another one going through Y, so I'll have partial W with respect to Y, times partial Y, partial S, finally going through Z, partial W, partial Z, times partial Z, partial S. And so there would be the chain rule for partial W, partial S. Now, you can do the same for partial W with respect to T. In the effort of keeping this video short and sweet, I won't go through that. In each case, it should look similar to this. Three terms, each one with two factors, but instead of with respect to S, these should all be with respect to T's. Let's look at another situation. Let's say we have a variable W, which depends on, it's a single variable function of Z. So we have W that just depends on Z, and then Z is a function of X and Y. And then X and Y are each functions of a single variable T. So here's our tree diagram for this situation. So I think actually I want here not dz dt, I want dw. I want dw dt, yeah. So what if I want dw dt? So notice that if we follow this down to any of the leaves of the tree, we just have t there, which tells us that w is a function of the single variable t. So that means dw dt, that's just a regular derivative, but we'll have to use some partials to get there. So if I kind of fill this out, right, I can compute w is a single variable function of z. So this is dw dz, and then z depends on x and y, so this would be partial z, partial x, and then x is a single variable function of t, so that would be dx dt. And similar over here, I would have partial z, partial y, and dy dt. All right, so let's figure out what is dw dt. Same thing in any case for any of these chain rules, start at W and find all the chains that end at T. We have two chains. Each is three steps, so we should have two terms, each with three factors. So this will be dw dz times partial z, partial x, times dx dt. And add that to dw dz times partial z partial y times dy. And that would be the chain rule for this situation. All right, that's it for this video. I'll see you next time.